dream is simple: speak a voice note into your phone, and your AI agent handles it, searches the web, writes code, manages files, and reports back in your ear. No SSH sessions, no terminal tabs, no browser dashboards. Just you, your phone, and a team of agents. This is a ruthlessly practical evaluation of every tool that lets you command AI agents by voice via Telegram, from OpenClaw to N8N to Eliza OS. We score 8 tools on 8 criteria that actually matter. Let's be precise about what voice-first agent control actually requires. When you record a voice note in Telegram and send it to your agent, the pipeline needs to complete 5 steps. First, receive the audio file from the Telegram bot API. Second, transcribe it accurately and fast without per minute charges. Third, route the transcribed text to an AI agent with the right context. Fourth, execute real actions using tools, not just reply with text. Fifth, report back, ideally also by voice, completing the loop. Most tools fail at step 1 or 2. Some pass step 3 but have no real tools. A few nail steps 1 through 4 but leave you with walls of text on a small phone screen. The full pipeline is harder than it looks. Each tool is scored 0 to 5 on 8 criteria. Voice input and agent capabilities are the core of the use case. Setup time and production readiness determine if it is actually usable. The 8 criteria are: voice input, does it natively receive and transcribe Telegram voice notes? Setup time, minutes to a working voice agent, or days of coding? Self-hosted and private, does your data stay on your machine? Agent capabilities, real tools like file system access, web search, and code execution. Persistent memory, does it remember across sessions? Model agnostic, works with Claude, GPT, Llama, and Alama. Customizable behavior, can you define personality and skills without writing code? And production readiness, does it actually run reliably around the clock? OpenClaw scores 37 out of 40, the highest in this evaluation by a wide margin. It is the only tool explicitly designed around the command your agent from your phone use case. When you send a voice note in Telegram, OpenClaw receives the audio file automatically. It pipes it through a configurable speech-to-text backend, Whisper locally, or any OpenAI-compatible endpoint, and delivers the transcribed text to the agent. The agent processes it and can respond by voice using text-to-speech, completing the full voice loop. This is the only tool in this evaluation where voice-into-voice-out works out of the box. The gateway architecture runs a single process handling Telegram, WhatsApp, Discord, Signal, iMessage, Slack, and Google Chat simultaneously. One process, all channels. The agent skills system, markdown files loaded at session start, turns OpenClaw from a chatbot gateway into a real agent platform. The community repository has over 100 skills covering web research, code generation, video production, browser automation, and more. Mux scores 25 out of 40. It is a local-first AI coding agent with a Telegram remote interface. Telegram is the transport layer, not the interface. You get the same agent, the same session history, the same built-in tools whether you are in the terminal or messaging from your phone. The use case is narrow and well-served. You started a refactor before leaving the office and want to check in from your phone. The critical limitation, Mux Telegram integration, is text-only. There is no voice transcription, no voice input, no audio response. If voice control is a requirement, Muxt fails immediately. This is not a criticism. Voice simply is not in scope for its design goals. N8N scores 25 out of 40. It is the most capable no-code tool for building Telegram voice agents outside of OpenClaw. Community templates wire a Telegram trigger to whisper speech-to-text, an AI agent node, and a Telegram reply node. 1,000+ integrations mean you can connect your agent to virtually anything. But N8N is a workflow automation platform, not an agent platform. Workflows do not have identity. They do not accumulate skills. They do not remember across runs without explicit database nodes. Getting persistent context requires connecting a database memory store, which erodes the no-code promise. Multi-agent coordination is not something N8N does naturally. Lindy scores 21 out of 40. It is a SaaS platform with 400,000 users for building AI assistants without code. The visual workflow builder is polished and Telegram integration is available. For the voice-first, privacy-first, self-hosted agent control use case, Lindy is not it. Voice input is not native. Your data flows through Lindy's SaaS infrastructure. You cannot run Lindy on your own hardware. It is optimized for business workflow automation, inbox triage, meeting scheduling, customer support handoffs. That said, if you want a quick, polished, no-code way to hook Telegram text messages to an AI that manages your calendar and summarizes emails, Lindy is excellent at that specific job. Eliza OS scores 26 out of 40. It is the most technically sophisticated framework in this evaluation. TypeScript runtime, Postgre SQL-backed memory, formal plugin system, multi-agent coordination. The official Telegram plugin is well maintained. Real production deployments, Eliza OS agents have managed over $25 million in assets. This is a serious framework. It was built for Web3. That is both its greatest strength and its most obvious limitation for personal agent control. Deploying Eliza OS as a personal voice agent feels like using a Formula One car to commute. Voice input is not handled out of the box. OGG transcription requires a custom plugin or preprocessing step. AutoGPT scores 18 out of 40 and CrewAI scores 19. AutoGPT pioneered goal-oriented autonomous agents. Telegram is not a first-class interface. It is a community plugin, not a core feature. Voice input requires significant custom work. CrewAI is excellent at coordinating teams of specialized agents with clearly defined roles and handoffs, but it has no native Telegram integration at all. You would need to wrap it in a Telegram bot manually. Both frameworks are impressive in their domains. Neither is suited for voice-first Telegram agent control without significant custom integration work. The DIY path scores 28 out of 40. Python Telegram bot plus Whisper plus Claude or GPT API plus your own agent loop. Total control, zero lock-in, no SaaS costs beyond API fees, model agnostic by definition. But you are building infrastructure. Voice transcription, session management, tool execution, error handling, memory persistence, deployment, monitoring, all of it is yours to write and maintain. A reliable voice-first Telegram agent built from scratch takes days of initial work and ongoing maintenance. For the use case of running a team of agents as your day-to-day interface, DIY is the right architecture in principle, but a poor choice in practice. You would spend more time maintaining the infrastructure than using the agents. The gap between OpenClaw and the field is large, almost entirely concentrated in one dimension: voice input handled natively. That single criterion separates a true voice-first agent interface from a tool where voice is a bolted-on afterthought. If you want voice-first, self-hosted, real agent capabilities, use OpenClaw. Nothing else handles the full voice pipeline out of the box. If you are a developer who wants remote terminal control via Telegram, use Muxt. If you want maximum control and will build the voice layer yourself, go DIY. If you're building Web3 multi-agent personas, use Eliza OS. If you want to automate inbox and calendar from Telegram without coding, choose Lindy for speed or N8N for self-hosting. The missing tool this evaluation reveals: a voice-first agent gateway that runs on mobile natively. Whoever solves on-device agent execution with native voice input and output wins this category outright.